So it is given an initial velocity of 40 meters per second at a point P, at P. The body decelerates uniformly and attains a velocity of 20 meters per second. So it decelerates uniformly and attains a velocity of this at a point X. Okay. The body is finally brought to rest, meaning from point X, the body's velocity continued to change, and it is finally brought to rest at a point M. Okay, so it decelerated further, so its final velocity became 0 at a point M. Now, if the time taken by the body through the whole journey is 20 seconds, and the distance moved from P to X is 200 meters, we have to calculate the deceleration of the body. So we are told that total time taken during the whole journey, the journey is 20 seconds. And we are given the distance taken by the body from P to X. So distance from P to X is 200 meters. We are to calculate I, the deceleration of the body. Okay, so let's look at it. Let's look at what they mean by the deceleration of the body. So concerning the motion from P to X, we have initial velocity 40, final velocity 20. We also have the distance traveled. Okay, distance from P to X to be equal to 200 meters. Hello, are we there? Are you with me?
Yes, please.
Yes,
Okay.
yeah.
So once we have U, we have V, we have X. Let's look at the appropriate equation that would help us find one of them. We are to find the deceleration. So which appropriate equation would help us find the deceleration here? Hello, quick one. Eresi, go ahead.
V squared is equal to U squared plus 2AS.
So using V squared is equal to U squared plus 2AS, we can find this because we have U, we have X. So let's put in our values. 20 squared is equal to 40 squared plus 2 by A by 200. Therefore, A would be equal to 20 minus 40 times 20 plus 40, all divided by 400, or 2 times 200. So 2 times 200. Please, is somebody lost here? If you're okay with everything. Is somebody lost? You see, right here, I'm just substituting the values, the V value, the U value. So, and then trying to make A the subject. Though I don't, but 20 squared minus 40 squared, when I send this to the other side, will be equal to 2 by A by 200. So that when you divide through by 2 by 200 at both sides of the equation, you have this. But 20 squared minus 40 squared, difference of 2 squared is the same as what I've done. Are you okay?
Yes,
Are you
please.
okay? All right. So please, you can also point your calculator squared 20 minus 40 squared and get your value. Okay. Because I am not using calculator, that's why I most often use that. So this is minus 20 by 60 divided by 2 by 200. Okay. So 1, okay, giving us minus 3 meter per second squared. Negative 3 meter per second squared. And this, anyway, let's continue to see whether this will be a uniform. Okay, let's continue to see. This is the deceleration during the first part of the motion where the body decelerated from P to X. Erasing.
Mr. Edia, please, I wanted to ask that. So if you're writing the deceleration, like you are concluding, will you write it is equal to negative 3 meter per second squared, or you write it's equal to 3 meter per second squared?
You see, both ways, you are not wrong. Because when we talk about deceleration, we all know it's a negative of acceleration. So ideally, when you are mentioning deceleration, you have to talk about the magnitude, 3 meter per second squared, because the word deceleration gives us the idea that it's a negative value. Is that okay? Eraser, are you okay?
Yes, please.
Right, but if you write it as the deceleration is equal to negative, nobody will penalize you. Really? Go ahead. And a quick one.
Mr. Isaac, please, when we're finding the deceleration, if I choose to use V is equal to U plus AT, will I get the same? No, I will get a different answer.
Let's see. And no, here, because you haven't determined the time within which the body decelerated from P to X. But if you have the time, you get the same answer. Are you okay? Really, are you okay?
Yes,
Hello.
please.
So having had the deceleration, you can use it to determine the time. Using the equation 1, V is equal to U plus AT. Your U is V is 20, U is 40, minus 3T will give you 3T is equal to 40 minus 20, which is this is 20. Therefore, T will be equal to 20 on 3. And this is 6 points. I think approximately 6.7. So this is the time. This is the time for which the body decelerated from a point P to a point X. Please, are we okay? Nanekia,
Celia, please, can you go over the time, how you are doing the time calculation? It's like I'm a bit confused.
you see, Nanekia, we have determined the deceleration of the body from P to X. And that is it.
Yes,
Okay,
please.
good. Now, once we have the deceleration, we can substitute it into equation 1. Okay, and to equation 1, to get the time because we have the final velocity 20, initial velocity 40, and now we now have the deceleration A. And so we could easily use that to find the time. And that is what I've done. Unless are you fine?
Thank you. Yes,
Good.
please.
So what's the next question? The next question demands that we calculate for. Please help me with the next question. I sent this to you, so quickly help me with the next question.
The distance between X and M.
Distance between X and M.
Okay, so we are looking for the distance between X and M. Now, once the total time taken during the whole journey is 20 seconds, then it means that the time taken for X2M must be 20 minus 6.7, and that will be 13.3 seconds approximately. Please, are we fine with the time? Hello, are we fine with the time?
Yes, please.
Good. Now using V squared is equal to U squared. Let's use the expression which will enable us to get the time. Using V, S is equal to UT minus half AT squared. Sorry, plus half AT squared. We can find the distance from X to M. Because what is our value of U for the journey from X to M? What's our value of U for X to M? Yes, Ama,
20 meters per second.
come again.
20 meters per second.
Good. And U is equal to 20 meters per second. Okay. And U is this. Then X is equal to 20 by 13.3. Okay. Now, look at something over here. Over here, look at something. We don't know A. Okay, this deceleration is not uniform because when the body comes to M, let me draw something. Let me draw the velocity time graph for the motion. Let's assume this is it. This is 20. This is 40. Okay, we calculated we determined the time over here and what's 6.7. Let me adjust the screen. And what's 6.7? So the acceleration 20 minus 40 on the time 6.7 would give us 3 meters per second squared. It means that the time, this is P, this is X, this is M. Class, I hope you are with me. Are you with me?
Yes, please.
Good. If this is 6.7 and I took a time of 20 seconds for the whole journey, then straight away this is 13.7. Okay. If 13.7, what is the final velocity at M? What's the final velocity at M?
0.
0. 0. So V at M is 0. Using A is equal to V minus U on T. This V is 0. U is 20. the time is 13.7. And this will give us a deceleration of 0.5 meter per second squared. Are you with me? Class, are you with me?
Mr. Dear,
Hello?
please, isn't it supposed to be 13.3?
We calculated for it. It's 13.3. Thank you. Good. So when you divide, you need to have a deceleration of negative or a deceleration of 0.5 meter per second squared. Are you okay with that? What it means is that,
No, please.
you see, we have the time from x to m, 13.7. Okay. Then the initial velocity at x is 20. The final velocity at m is 0 because the motion has come to a stop. Okay. So having u, v, and t, can't you calculate for the acceleration between x to m? Can't we do that?
We can.
Good. You see, what it means is that look at the acceleration from p to x. We got 3 meter, negative 3 meter per second squared. Look at it from x to m. It means that the motion is not a uniformly decelerated motion throughout. Okay, from x to m has its own value of deceleration, and from x to m also has its own value of deceleration. So it cannot be this straight. If it is this straight, then whichever 2 points we take, we need to get the same value.
Mr. Dear,
Hello.
please, it's 1.5.
When 20 divided
Yes.
by 13.3.
Yes, negative 1.5.
Thank you. So we have minus 1.5 meter per second squared. Okay, so the motion cannot be this straight. If it is this straight, then whichever 2 points we pick along the line must give us the same value. Class, do you get me?
Yes, please.
As we have learned under uniform accelerated motion and uniform decelerated motion. So this graph must be bent. You see the deceleration here is less than the deceleration there. So the gradient will have to slope a little bit. Okay. Yes, it must be this, and this is m 13.3. So that is the reason for the solution I sent you. Having calculated for the deceleration from x to m, then we can go ahead to calculate for the distance. Let me adjust the screen once more. We can go ahead to calculate for the distance. Half by 1.5 times 13.3 squared. Please put them together and then give me the feedback. Amma, I'm listening. Hello,
Sir.
Amma.
Sir, please, can you hear me?
Yes, I can.
Okay, sir, please. So if the acceleration from m to x is different from p to x, why didn't you do it for the I? Since the I asks, we should find the deceleration of the body, which is like deceleration. So why didn't you solve that one for I?
Come again. Why didn't I solve what?
The acceleration from x to m. Why didn't you add that one to I? I's answer.
No, they are not the same.
Yes.
They are not the same. The deceleration from p to x is different from the deceleration from x to m. You can't add. They are not the same. Okay. For uniform decelerated motion, whichever 2 points you pick along the line to calculate for the slope, you need to get the same value. So if it's a uniform decelerated motion throughout, then if I pick from P to X, what I get must be the same as from P to N. And we have demonstrated this severally in the previous solution or questions we've answered. Okay. And once it isn't the same, it means that the body decelerated differently from P to X and also decelerated differently from X to M. Are you okay?
Okay, sir. And
Yes.
please, so if we come across questions like this,
Yes.
and maybe they state that we should find the deceleration of the body, we just need to find the first part of the body.
Exactly. Exactly.
Okay, thank you.
You see, one thing that I saw is that if you use the 3 meters per second squared throughout, okay, the answers you have will be different from when you use the graph. Don't forget that we can use the velocity time graph to find everything they are demanding for, being it the time, the deceleration, the distance, and all that. If you use the uniform decelerated motion of 3 meters per second, what you have
Okay,
for using the equation will be different from when you use the graph. I don't know if some of you have given that a try. If you've tried using the two graphs, the graph and then the equations of motion to solving the same question. Okay. When you do it, that is the result. All right. So please, what did we get for the distance? What did we get for the distance between X to M? Is it 133? Akosia free, are you there?
Yes,
Akosia. What did we get?